Good day to you, grade 12 learners. Welcome to today's mathematical literacy lesson. My name is Bernard Donko. This lesson is brought to you by the Northern Cape Department of Education in collaboration with Pagama Research and Development. So as we go along with our lessons, today we want to focus on measurements. And in particular, we want to deal with volume calculations and how to deal with BMI. So please stay tuned and let's get into it. At the end of the lesson, what I'm hoping that you would know and understand is you should be able to understand the basics of conversions and know how to substitute. You should be able to visualize 3D objects or shapes and understand the concept of an open and closed container and how it impacts on the formula given. So basically, like if we have a box that is closed, it is going to be 6 sides. But if the lid is not there, it's going to be 5 sides. That is what I'm talking about. We'll go over it as time goes on. You should be able to calculate or measure volume using objects consisting or representing squares, rectangles, circles, or triangles using known formula. So by your syllabus, whatever you're going to be writing, we have to give you the formula so that you can substitute and do the appropriate calculations. So don't worry so much about cramming every bit of the formula. You should be able to determine and calculate appropriate quantities of materials, components needed. Also, you have to be able to calculate the cost of materials or components needed to complete a task. These are the things, these are the subtopics, these are the areas where we will be setting questions and asking you in examination. So whenever we are doing these things, just be sure that you understand every portion. Where you feel that you don't understand completely, pause the video, watch over it again, try to ask questions even from your teachers, and I'm sure everybody will be willing to assist you with that. So for us to go on to the topic of volume and BMI, your knowledge about conversions and calculation of volumes from the grade 10 and 11 ideas will be very, very important. So take note of that. Now, let us do the first baseline assessment so that we can see what do we know and what do we have to do or try to learn more. So the first part says the rectangular long jump pit at a certain school is 2.75 meters wide and 9 meters long. This is the 2.75 meters. This is the 9 meters long and is filled with sand. So here I've given you how deep it is, say 70 millimeters. But if you can notice, the first thing that is different there is that the 70 has different units, and then the other two numbers have also got different units. So it means that along the way we need to convert and make sure all our values are at the same unit. Number 1.1, calculate the volume of sand needed to fill the long jump pit to a depth of 70 meters. So millimeters. So when you see depth, sometimes that is how in MathLate we write height. So whenever you see depth, you mean we are talking about how deep or how high the object is. Give the answer rounded off to 3 decimal places. Use the formula volume is equal to length times breadth times height. 1.2, would you say that the sand used is enough to ensure that learners do not get hurt? Explain. So these are 2 questions. I would like you to attempt them quickly. Can we give ourselves just 3 minutes because we are just substituting and expressing ourselves. After 3 minutes, we'll come back and continue with that. Okay, welcome back, learners. So let's look at how you were supposed to attempt this question. Remember what I was telling you. The 70 is in millimeters. So it is your responsibility to convert it to meters. How do you do the conversion again? The moment you get the question paper, write your conversion values: kilometers, meters, centimeters, and millimeters. From kilometer to centimeter to meter is 1000. Meter to centimeter is 100, and then centimeter to millimeter is 10. If we are moving from small to large, we are going to divide. If we are moving from large to small, we multiply. That is how you do the calculation. So I'm just showing you how did I get the 70 millimeters. Remember, it is millimeters. I'm taking it to meters. I'm coming here. So I have to divide by 1000 because I'm coming to meters. So if you divide 70 by 1000, we are going to get 0.07 meters. So now that we know all the values are the same unit, what we do is to substitute. Remember, the examiner gave you the formula. It says use the formula length times width times height. So the length was 2.75, the breadth is 9 meters, and then the height is 0.07. When we press together with me, we're going to have 2.75 times 9 times 0.07, and then you're going to get the answer as 1.7325 meters cubed. It is meters cubed because each of the values has meters, each one meters. So 3 of them is meters to the power 3. That's why we're having cubed. And again, when we are dealing with volume, please remember that the unit is always to the power of 3. So 1.2, the question was, is the sand in the pit enough to ensure that learners do not get hurt? It was a question that the examiner was asking you, meaning we expect you to express yourself. So it's only 70 millimeters high. I said no, it is not even a third of a ruler. So learners will land on a very hard surface that could result in injury. What we are saying is you may not be able to write it the same sentence like I am showing you here, but the amount of sand in the pit is very less. So you can just say, no, it is not enough. It is not high enough. So learners can end up getting hurt. All right. So as we deal with volume, let's look at some few things we have to take note of. Let's look at our terminology. The first one is imperial system. Whenever you see that we are using imperial system, we are talking of a system of measurements such as inches, pounds, ounces, feet, gallons, miles. Those are imperial. Then, if it is not imperial, we have what you call the metric system. So under the metric system, we have those ones like meters, kilometers, kilograms, centimeters, millimeters. Those are what we call metric. So in the maths lesson, we have what we call the metric system and the imperial system. All right. Then along the way, most of our work will be using pi. Pi, I've explained to you that is the Greek letter P, the ratio of the circumference of a circle to its diameter. Meaning when you take any object that is round, the length that you get divided by the diameter of that round object, you are going to get 3.142. That is why in examination all the time you see that we are giving you 3.142. Then we have radius. Whenever we see radius, you must know it is what? Half of the diameter. Or you can say it is the distance from the center of the circle to any point of the circumference. The reason we are learning these things is because sometimes the examiner will give you questions where they will say, explain the term radius, explain the term circumference, explain the term surface area. So you have to be sure that you do understand what we are dealing with. Then we have surface area. Whenever you see the word surface area, you should know that we are talking about the area of all the surfaces. So if a box is closed, there are 6 sides, meaning the area of each and every side of the box. That's what we call surface area. Sometimes in examination, you'll find the examiner says, calculate the total surface area. Then we talk of volume. So whenever you see that we are writing volume, it is the amount of 3D space occupied by an object. So volume is what? The amount of space occupied by an object. It is measured in cubic units, meaning to the power of 3, like meters cubed, like centimeters cubed, like millimeters cubed. I hope you understand that. So whenever we talk of volume, you must know it's the amount of space inside a hollow 3D object. So if you have a water bottle, inside the water bottle, the amount of liquid, amount of water that we can pour in the water volume is what we call the volume. Then here is the point where I want you to take note of. You see, we have volume and we have capacity. So when we talk of volume, I've already explained it, but capacity, it refers to the amount of fluid in the container and is measured in milliliters, liters, or let's say kiloliters. Capacity is a metric system way of measuring liquid. So if you can also remember it this way, you can say capacity is the amount that can be contained in an object. The quantity of object that we can contain in a 3D container, we classify it as a capacity. And I've shown you to say with volumes, we measure them in millimeters cubed, centimeters cubed, and meters cubed. All right, so now let's look at this information here. It says the information below shows some common conversion ratios for volume. So here, every time you see that you have 1 meter cubed, it's the same as 1,000 liters. Meter cubed, that is a solid. Like for example, if you have ice, you see ice is cold, but you can hold the ice. So we can find the volume as 1 meter cubed. But if you allow the ice to melt, it becomes liquid. Then the volume will be measured in liters or milliliters or kiloliters. 1 centimeter cubed is the same as 1 milliliter. So these are conversions where you find that once you get any question paper, the examiner will be given to you, expecting you to apply them, expecting you to show how to convert objects. So now let's look at it. As we talk of volume, let us look at the formulas that we can use. So if the object is a rectangle, then the formula is volume equals length times width times height. Sometimes it is a cube, meaning all the sides are equal. So in that case, the formula will be side by side by side. Why? Because it's a cube, and therefore all the sides are the same value. So we just say side times side times side. If the shape is a cylinder, then we have volume equals pi r squared times height. What do we have? Pi r squared times height. In the examination, the examiner will definitely give you the formula so that yours is to convert and ensure that all the values that you are dealing with are the same unit. After that, you just substitute, convert to the way the examiner wants, and then you get marks. If the shape is a triangular prism, almost like half of a rectangle, cut it from the top to the bottom, you're going to get a triangle. And the formula will be half times base times perpendicular height times the height. All these things, I don't want you to just cram them, because in the examination, the examiner will give them to you. Ours is to know how to use them. So let's look at how do we get to use all these things that I'm talking to you about. Jabu wants to know how much rainwater a tank like the one alongside, like this one, can hold. The inner radius of the tank is 0.998 meters, and the inner height of the tank is 2.498 meters. So the first question they're asking, calculate the total volume rounded to 3 decimal places of the water tank. We need to find the volume of this water tank. And then number 1.2, or before 1.2, 1.1, it says use the formula volume of a cylinder is equal to pi times radius squared times height, and the value of pi is 3.142. So if you can see the same value of pi right from grade 10, 11 up to grade 12, there's nothing that changes there. And then 1.2, determine the height rounded off to 3 decimal places of the rainwater in the tank when it is 80% full. So here they are saying the water in the tank is not completely full yet, it's only up to 80%. We are supposed to find the height. So can we attempt this just for 5 minutes, learners? And then after 5 minutes, we will come and show the answer together. All right, welcome learners. So this is how you're supposed to consider it. You see, the examiner gave you the formula as volume of a cylinder equals pi r squared h. So one of the ways that you can work is write down the values. Pi, you know, is 3.142. Your radius is 0.998, not 2 because it was a squared, 0.998, and also 0.998, and the height will be 498. So once you have all these values, then what do you check? You ensure that all the values are the same in terms of the unit. So if one of the values is in millimeters, the others are in meters, then you have to convert all of them to either millimeters according to what the examiner asked you, or convert everything to meters according to what they are expecting you to do. So what we are doing here is to substitute all the values, and when you substitute, you should get 7.812 meters cubed. Can you please pause the video, check for yourself, ensure that you are able to get the same answer that the examiner is giving to you. Remember, if it is not correct, go over it again, check and see if you have made any mistake or not. If you can see here, I said radius squared, but when I'm writing it, I'm writing the radius twice. Radius, and when I say twice, it doesn't mean times 2. All right, let's look at 1.2. We are supposed to find the height of the water in the tank. Remember, the height of the inner side was 2.498. So what are we doing here? What we are doing is to find 80% of 2.498 because it was not completely full. So we'll be saying 80% of 2.498, and that will give us 1.998 meters. All right. So now, since we have done some few examples, can we go back and do some activities where you have to sit, write, do the work, and let's see how it goes. So the first one, a school builds a swimming pool with the following dimensions. The length is 15 meters. The depth, remember I said to you the depth is the same as the height. So the depth is 1.3 meters and the width is 5 meters. So they have given us all the three values, length, width, and height. Then they said, take note, 1 meter cubed is the same as 1,000 liters. And 1,000 liters is the same as 1 kiloliters. So now that they have given us all these values, those values as you see as in 1 meter cubed equals 1,000 liters is what you call conversion factor. How do we say it? Conversion factor. So basically for you to convert, the examiner will give you a conversion factor. Once you do your calculations, then you are able to convert to the unit which is needed. So let's look at 1.1. Calculate the volume of the swimming pool up to the level it is filled. 1.2. Convert this volume, that's the answer that you got. First, 1.2.1 to liters, 1.2.2 to kiloliters. So you are working, but you see the examiner is asking you, trying to see if you understand how to do conversion. 1.3. When the school fills the pool, they use a pump which pumps water at a rate of 2 liters per second. How long will it take to fill up the pool? Give your answer in hours and minutes. So we have 1, 2, 3, 4 questions. We are taking only 6 minutes. Let us work on it quickly. Pause the video, try to use the conversion factors, get the answer. We'll come back and discuss together. Welcome back, learners. So now let us see how we are going to do this. There are the conversion factors. I've brought it back again so that we do not forget, because I don't want you to keep on going back and forth. You will end up forgetting some of the items. And then I've also shown you here how do we convert in terms of the metric. So we have millimeters, centimeters, meters, kilometers. You will have to know this. This portion they don't give to you in an examination. They only give you a small portion so that you can use it. So always try to see, once you get your question paper, draw this on the page. Remember, the page is yours. Draw it on the page so that it can help you. When it is time for you to convert, you will know what to do. So the first one, find the volume, is going to be the length times the width times the height. So it's just 97.5 meters cubed. I hope you got it correct. All right, let's look at 1.2.1. They wanted us to convert the answer from meters cubed to liters. Meter cubed to liters. Every 1 meter cubed that you have is the same as 1000 liters. So now that we have 97.5, we multiply by 1000, and that is going to give us 97,500 liters. How about now we are converting to kiloliters? Remember, they said to us 1000 liters is the same as 1 kiloliter. So remember, now we are having 97,500 liters. So how do we get it? We are going to divide it by 1000, and that will give us 97.5 kiloliters. Then they said we should continue and keep working. So here we have our 97,500. We divide by 2. That is going to give us 48,750. Why are we dividing by 2? Remember, 2 liters per second. It's only able to fill at what? 2 liters per second. So the 97,500 liters divided by 2 liters, meaning we are going to need to fill it for 48,750 seconds. Then what you see me dividing by 60 here means I am converting it from seconds to minutes. That's why you see 812.5 minutes. Now that we have in minutes, I want it in hours. So I'm going to say 812.5 divided by 60. It will give me 13.5416667 hours. But remember, there's a portion, not the 13 hours, the 0.5411. You convert it to 60, you're going to get 32.5 minutes. So now what will be the total time? It will be the 13 hours, 32.5 minutes. That is how long it will take to fill up the pool. Now, I've given you the same information here. So let us go on with 1.4. I've given you all the measurements. That way we don't have to keep on going back. So we are saying that the pool needs to be filled. Every liter, every kiloliter, they charge you 8.64. So 8.64 times how much water in the pool, which is 97.5 kiloliters. That is how you see me getting 842 rand and 40 cents. Then we have 1.5. It says we are supposed to find the height as to where it got full. So we have the whole 1.3, we minus the 1.24, meaning it's only used at 0.06. What are we talking about here? Remember, the examiner asked you the question to say, when learners started swimming, the water level reduced to 1.24 meters, meaning it was not the whole 1.3 anymore. That's why you see that I am subtracting 1.24 from the whole height, meaning how much water has gone away? 0.06 meters in terms of height. Okay, now that we know that, let us use the 0.06 to find the volume of water, because this is just the height. So we will be saying the 15 times 5 times the height, which is gone now, is 0.06. We are going to get 4.5 meters cubed. Convert it to liters. That's why you see I am multiplying by 1000, and then we are going to get 4,500 meters. So I hope you managed to get all these things correct, because now remember, whatever you know from grade 10, we are building it up also for grade 11 and 12. So everything that you learn, please remember not to forget them, because you will need it as you go further. Now we are looking at BMI. BMI, the full meaning is what? Body mass index. Let's say it again, body mass index. So for us to determine a person's body mass index, we are using the height of the person as well as the mass of the person. It will give us an idea of whether this person is healthy, is not healthy, is obese, underweight. We have different names for that. So let's go over and see the terminologies. The second one that we are looking at is the full meaning of BMI. That's why I've written here body mass index. So whenever we talk of body mass index, we are talking of a number that is calculated from an adult's weight and adult's height, and then the answer we express is in kilograms per meter squared. We'll be doing some examples so that you will know how it works. Height, of course, like the height of the person, And then when we say measure, meaning use an instrument like a ruler and take a measurement. That's what we mean by measure. When we talk of weight, sometimes in mathlet, we use weight and mass interchangeably. So do not get confused if, let's say, during the exam they use mass instead of weight. You don't say, no, my teacher did not say we must use mass. We use mass and weight interchangeably. So now, we know that BMI is used for adults to determine whether the adult is of normal weight, underweight, overweight, or obese. But I want to make clarity here that it is not only for adults. We even have for children. We have for learners who are in school, because we need to check to see the weight status of the person. All right. The second point, the weight status is used by health practitioners to provide appropriate advice. So as we learn this one, you should know that you are not yet a doctor. You are not a specialist where you can say, from now on, I can decide and I can check whether somebody is healthy or not. You are only interpreting here, trying to get marks for you to pass. So it does not mean because you have done BMI, all of a sudden you are a doctor. You are not yet a doctor. Take note, for children and teenagers, growth charts are used to determine their weight status. So we have what you call growth chart. We will see some along the way. It will help us. That's why I was saying it's not only for adults. We also work for BMI for even teenagers as well. Now, the question is, how do we calculate BMI? So for you to calculate BMI, you use the weight of the person divided by the height in meters squared. That is why you see the unit as kilogram per meter squared. The weight or mass of the person divided by the person's height. All right, so let's move on to the next point. During examination or most of the exam question papers, you will see the examiner will give you a table like what you are seeing here on the screen. So if you calculate your BMI and the person is, the answer that you get is below 18.5, we say that person is underweight. If the answer you get is between 18.5 up until 24.9, that's when we say the person is normal or healthy. If your answer for the BMI is from 25 up to 29, any value there, we'll be saying the person is overweight. In some books, in some examinations, they will write at risk of overweight. At risk of overweight. So it's not just overweight sometimes. And then if the answer is 30 or more, then we say the person is obese. That means the person is having a very big BMI. So let's look at word example. It says the table is used to calculate the values to confirm the correctness of it and weight status of learner 4. So we are just talking of any random learner, say learner 4. Maybe it's your friend. We are just making it up here. The mass or how heavy the learner is 70 kg. The learner is 1.7 meters tall. The BMI for that learner is 24.22. The weight status we are saying is normal. So here we are just checking, we are confirming if the values are correct. So first, how do we determine the BMI? We say the BMI is what? The mass or weight divided by the height squared. So what is the mass? 70. Height squared, that's why you see I'm writing 1.7. But you see where the 2 is? It is outside the bracket, meaning it's 1.7 times 1.7. And if you can check that, let us try and see if we can get the answer. So it's 70 divided by, then you can open bracket and say 1.7 times 1.7. You close the bracket and there we go. The answer is 24.22. 24.22. If you are using a Casio calculator, you will see that there's so many letters or so many decimal places. You can actually press Shift Mode 62. If you press Shift Mode 62, it's gonna cut everything to only 2 decimal places. All right. So now we know that this learner is 24.22. So what do? We go to the BMI table. This is our BMI table. Remember, I've given you the values already. The examiner says if your answer is somewhere between 18.5 up to 24.9, then we say the person is normal. So from what we are checking here, this person is normal. That's why you see We're having normality because the answer, we find it between 18.5 up until 24.9. All right, so now let us check, how do we determine the length of this person? The length, we are talking of the height, how high the person is. Okay, so remember the answer was 1.7. But in examination, if the examiner says calculate the height, you use this formula. Height is going to be equal to, let me write here, height is equal to the weight or mass of the person divided by the BMI. What was the weight again? 70 kilograms. The BMI, 24.22. Can you see this square root sign? So when you are pressing, what you do is you first press the square root sign is on your calculator. You should see it, the square root sign. Then after you press, you can press your divide button. It will give you this way. So what you do first, after you have pressed the square root sign and the divide button, then you press 70 at the top, and then you shift it down and you press 24.22, and then you press equal to. You will see that you will get 1.70 meters squared. So whatever the case, just make sure this formula, most of the time the examiner doesn't give to you. They will only give you BMI is equal to weight over height squared. But you have to arrange the formula so that you can find the height. That is what you have to learn to do. Okay, now that we know the height, we know the BMI, let's see if we can find the weight. So we see we managed to get the normal status, we got the BMI, we have gotten the 1.7. Now we want to see if we can get 70. So what we do is to take the formula and arrange it again. Remember the formula says BMI equals weight over height squared. So now that we are looking for weight, then it's going to be BMI times height or length in meters squared. Again, look at where the squared is. It is outside of the bracket. All right, so let's go. The weight is now going to be the BMI 24.22 times height of 1.7 times 1.7, and you will see that we are going to get approximately 70 kilograms. I hope it is helping a lot. Now it is your turn. I want you to let us work. Let's do this activity and see how far it takes us. Says number 1, BMI is used to determine the weight status of a person. An educator used the BMI growth chart below to determine the weight status of girls at a school. So if you can see here on the growth chart, this is what we call growth chart. So if you can see on the growth chart, there are lines. Can you see the first line? If you are under or around the 3rd percentile, we say you are underweight. Anything from the 3rd up until the 50th, we are saying you are normal weight. If you are around the 95th percentile, we consider you to be having risk of overweight. And then if you are above 97, then we say you are overweight. You are no longer at risk. So let's look at our first question here. An 11-year-old girl's BMI is on the 85th percentile. Determine her BMI. And then number 2, explain what it means if a girl has a BMI for age relationship that is plotted on the 65th percentile. So these are typical exam questions that the examiner wants you to respond. Can we attempt these two? Let's give ourselves just 3 minutes. I think it should be enough. Let's give ourselves 3 minutes and see if we can get this answer. So for you to answer this one, you have to work with the growth chart. After 3 minutes, we'll come back and then we discuss the answer together. Okay, welcome back, my learners. So the first one, the examiner said a 11-year-old girl's BMI is on the 85th percentile, so somewhere here. Determine her BMI. So this is how you work it out. You go to the 85th percentile, you will see that the BMI is 20. Remember the BMI table that I gave to you. All right. 1.2, they are saying that it is plotted around the 65%. So the long story short is that the value that the examiner gave to you, you must make sure in the end you get 100. Meaning if the examiner give you 50, the other value must be 50. If they give you 70, the other value must be 30. It must always add up to 100. That's why you see 65 and 35 here. Then what do? You'll be saying it means 65% of girls the same age, their weight is below that child. And then 35% of those learners, their weight is above. So what we are looking for is 65% below the weight and 35% above the weight. That's how you answer the questions. All right, let's look at 1.3. A 16-year-old girl's BMI is 27.1. That is the BMI. Use the BMI growth chart and write down only the letter that represents the 16-year-old girl's weight status. If the BMI is 27.1, where do you think the answer will be? This one, it doesn't have to take long. Check quickly, 1 minute, and then we reveal the answer. Did you manage to get the answer? The answer is B. B, or risk of overweight, because the BMI is above 24.9. Remember the table again. Okay. Then let's look at question 1.4. A girl has a BMI that lies on the 95th percentile, somewhere here. Remember, we are saying this learner is now already at risk of overweight. So they are asking you in the exam that you have to advise this girl on possible lifestyle changes that she can make to decrease her BMI. How do we do this? Write something that what kind of advice will you give to a learner who we consider to be at risk of overweight? Just write your answer, then we will discuss together quickly. I'm giving you only 2 minutes. All right, so this is the kind of advice you can give to that learner. Currently, you see that the BMI is very much high, is at risk. So what must the learner do? The learner can follow a healthy diet. The learner can do exercises. The learner can go to the doctor for the doctor to prescribe what they can do to lose weight. So here we want you to express something. Basically, when we give you such questions in the examination, we want to test and see if you, the learner yourself, if you find yourself maybe at a risk of overweight, will you be able to explain how you're going to lose weight? Because if I ask that this learner is at risk, what must we do? Something that can come to your mind like, try to go on a diet, try to exercise. These are common things that we expect you to say to us. All right, so now let's look at number 2. A runner became ill during the race and was taken to the doctor. The doctor recommended that he takes 11.5 milligram per kilogram of an antibiotic per day. The antibiotic is available as 150 milligram capsule. If the runner has a BMI of 28.6, can you see as we work, you highlight 28.6 and is 1.6 meters tall, show using calculations that 6 capsules will be the correct dosage for the runner per day. How many capsules? 6. And they are saying we must show. Show means we are working to prove the same answer, meaning that the answer is correct. So ours is to show to prove. And then they said you may use the formula BMI, mass or weight in kilograms over height squared. Here you have 5 minutes. Let's work on it quickly, then we'll come back to discuss together. All right, welcome back, learners. So if we look closely at the question, they gave us the BMI and they gave us the height, meaning we are left with the mass. And how do we find mass? Is BMI times the height times the height. That's why you see here, there's the mass times height, meaning the mass of this athlete is 77.8635 kilograms. What do we do with this information then? Then what we have to do is to go on and check the antibiotic needed. Remember, they said what? 11.5 milligrams per every kilogram. So it's now 11.5 times the mass of the athlete. That will give me 895.43025 milligrams per day. So number of capsules that we are going to get, what do? We take the number of capsules that we need per day, divide by the size of the capsule, which was 150 milligram. That means that we're going to get 5.9695535. Round it off is approximately 6 capsules. Remember, you were working to prove it. If it is confusing to you, pause the video, check how do you answer such questions, because these are the ones which will give you a lot of marks, and we hope that you do not skip them. All right, so now it's your time to take these things home, where you go and do a bit of homework. So we are continuing, but here we have Ruth, and we want to ask questions about it. It says Ruth is a mother of two twins, Nick and Nicolene. She is very health conscious and regularly monitors their body mass index. On a particular day, she recorded the twins' mass and height as follows. So here you have been given the information. Please take note, 1 centimeter is the same as 0.3937 inches. So you have the questions that I've given to you there. I expect you to answer them so that you can boost your memory. So what have we talked about today? We have spoken about volume as well as BMI. I've explained to you what is volume and what is capacity. So now in our next lesson, we want to try and focus on taxation. Please try your best to tune in so that you don't miss this important lesson. On that note, I would like to thank you so much for being with us, and I hope you learned a lot. See you very soon. Bye bye.